Hello everyone, we are going to look at bonding today. We are going to specifically look at what ionic bonding is and how to draw ionic Lewis structures. I'll have another video about covalent and covalent Lewis structures. So let's begin. Alright, just as a reminder, the valence electrons for our talked about elements are the group number above. You probably wrote down on your periodic table 1, 2, skip a few, 3, 4, 5, 6, 7, and 8, with helium being the exception. Hydrogen and helium, remember for the octet rule, hydrogen and helium only want 2 to fill out that outer shell. Okay, if you don't have that on your periodic table, maybe you should write that down just so you could glance at it and look at it and go a little bit quicker. But other than that, let's continue. All right, so Lewis dot, all right, also called electron dot diagram, is when we write down the symbol of the element. We look at the number of valence electrons. All right, that's from your periodic table. We just had that slide about it. You start in one direction, you place a dot, and you keep going around, putting 1 in each direction until you have to double up, and then you stop when you run out. Note, because we are talking about valence electrons, you will never have anything more than 8. All right, so if you have a symbol with like 16 dots on it, you're wrong. You did it wrong. Go back and check for the correct number of valence electrons. All right, so let's go ahead and work out these two examples. All right, so if we look up calcium on the periodic table, we're going to find out that it has 2 valence electrons. So I'm going to put a dot in one direction, and then I go to each direction until I run out. All right, there we go. We could see that we have 2 electrons in different directions. All right. This answer, all right, is wrong. We know we don't have that. All right, we have to fill up each position before we double up. All right, it has 2 places that it would like to make a bond. All right, let's go on with fluorine. All right, we look up fluorine on the periodic table. We can see that it has 7 valence electrons. So we go through 1, 2, 3 in each direction. Oh, we got to double up now. And then 7. All right, so there is only 1 lone little electron here. These other ones are paired up. All right. Now, we already know things make bonds to get that full outer shell, and that's what we're going to be working on today. All right. We also know that once ionic compounds make that bond, you got some ions in charge there. You got some ions moving around and doing stuff. The charges you should already have on your periodic table. If not, you should probably write these on your periodic table. It goes +1, +2, +3, positive, -4, -3, -2, -1, and 0. All right, this is based on whether it is gaining electrons. Remember, if we are gaining electrons, we're going to become more negative. So that would include all of these right here. And if we're becoming positive, so if we're becoming positive, we're losing electrons. And that are these right here. All right. So that's what happens. Something to keep in mind. Also something else to keep in mind. If it's a number that's in superscript up top with a positive or negative, it represents the charge of an ion. Okay? It's not a number of how many elements there are, it's just the charge of that single element. Note, it immediately follows the symbol. All right, and yes, you need to write both the positive and negative sign. I know some people are like, well, if it's positive 2, I could just say 2. No, make sure you have the positive sign. All right, but if the number is down below, in this case, that is a subscript. That is saying that I have 2 hydrogen. All right, it immediately follows the number that it's the element that it's describing. Okay, so there's two types of bonds, ionic and covalent. We're going to talk about ionic today and look at its Lewis structures. Ionic, the force of attraction between the opposite charges of the ions in an ionic compound. Electrons are transferred. Transferred, that means one element is going to give its electrons to another. When you transfer, like, say, money from a bank account to the other, all right, the original person doesn't have ownership of it anymore. The second one does. Well, in this case, it's going to make a chemical and physical bond between these two elements. A little bridge. All right? That's an ionic bond. It's a bond between ions. It's even in the name. Okay? Well, what is bonding? Well, you have a cation, which is the metal, and the anion, which is a nonmetal. You have to have at least one of each. All right? The cation is positive. All right? It even has a nice little plus sign in the middle of it, or you could remember the joke that I said over here. Cations are positive. No one laughed at that joke. It's okay. And then anions are negative. They're nonmetals. Okay, so an ionic bond has to have that metal. And in all these examples, the metal is coming first. All right, a good test right here, a good test to see if it's a ionic compound is to look at the very first element. All right, if it is a metal, follow it by something else. All right, without much brain work, you could assume that it is ionic. Now, there are exceptions to these rules, but for the most part, just look and see if that first one is a metal, and you'll know that it's ionic. All right, so now we're going to look up Lewis structures for ionic compounds. This is pretty much the way that I would like for you to do it. All right, before we go on and learn anything else about bonding, this is our introductory way of doing it. All right, so we have some steps that we got to follow. All right, how to draw Lewis structures for ionic bonds. How can we show what these electrons are going to do in a really basic form? So, step 1 says we draw the Lewis structures for each element. Note, I am putting the metal first. All right, so I have for salt, this is table salt, NaCl. All right, I draw the Lewis structure for sodium. I drew it for chlorine. All right, number 2, decide where the electrons are going to go. They're going to leave the metal, the cation, and go to the anion. All right, this lone pair right here has to go where he would fit in over there. He cannot go with the little pairs around chlorine. All right, that's no room for him there. He has to go to the open spot. So we draw an arrow showing that electron's going. And then lastly, we redraw the Lewis structure, complete with the charges. All right, note sodium has no electrons anymore. All right, and now he has a charge. All right, now he's an ion. And then I got chlorine over here with all 8, a full outer shell. And now it has its charge. All right, well, sure, learning steps and stuff is all right, but let's go ahead and look at an example where we have multiples. So in this example, I had one metal, one cation, calcium, and 2 anions. All right, we could see that the calcium had an electron here, and it went to this open spot, and then it had another electron right here, and it went to this open spot. Okay, in this case, it gave up 2 electrons, that's why it has a positive 2 charge, and each chlorine is a negative 1 charge because it accepted 1 electron. Excuse me, I'm coughing. So, let's practice. All right, I got copper and I got oxygen. Okay. I got oxygen. All right, we looking in our sheet. We got copper having a 2 valence electrons right here to donate. All right, it's a transition metal. It's a little bit funnier. All right, but in this case, we talked about how it's going to have 2. And then we have oxygen. It has 6 valence electrons. Okay, how can we have a Lewis structure for this ionic bond? Well, we see that we have 2 single electrons over on copper and 2 open places on oxygen. So what you would do is you would draw arrows showing the electrons leaving copper and going to oxygen. Copper leaving copper and going to oxygen. Okay, and then at the very end, we'd have our little brackets, copper with a positive 2 charge, and oxygen with all 8 and its negative 2 charge. So there we go, that's what it would look like. Make sure you review your homework. If you were in my class, ask me questions, watch the video again if you need help, and we will get there together.